Estamos ante todo, estamos en un congreso científico, el SHIFT, esta es la parte divulgativa del congreso, Talks and Music, y 100 universidades, 25 países, 250 personas, la Universidad de La Laguna revolucionada estos días, ¿verdad, vicerrectora? Todas las salas cogidas en la central. ¿Y todo esto para qué? ¿De verdad? ¿De verdad son tan importantes los congresos científicos? Yo creo que sí. No lo voy a decir yo, lo va a decir Heisenberg y Niels Bohr. Los congresos científicos de los más importantes de la historia fueron los congresos Solvay, que se celebraron en Bruselas entre los años 20, empezaron en 1911, pero los más famosos son el año 1927, 1930, 1933. Y pasado el tiempo, el propio Niels Bohr reconoció en el congreso Solvay en el 12 de 1961 que esta serie de conferencias habían sido ocasiones únicas para los físicos para discutir los problemas fundamentales que habían sido interés de su época y habían estimulado el desarrollo de la ciencia moderna. Y Heisenberg, premio Nobel también, decía que los congresos habían sido un ejemplo de cómo unas conferencias bien organizadas y planteadas pueden contribuir al progreso de la ciencia. Y tanto, buena parte de la tecnología que nos rodea hoy en día, la nanotecnología, desde la nanotecnología a la era atómica, nacieron en esos congresos. En 1930 y 1933, con Heisenberg, con Madame Curie, con Bohr, con Einstein, con su presidente, el chairman de ese congreso, Langevin, y con un canario, el único español canario que estaba sentado en esos congresos, Blas Cabrera Felipe, nacido en Lanzarote, criado en La Laguna y se desarrolló en Madrid, conocido como padre de la física española, porque fundó el primer instituto de física en España, pues estaba sentado ahí, en esos congresos. Ha pasado mucho tiempo. Hace tan solo una semana se celebró el Congreso Solvay, el 27 Congreso Solvay de Química, entre los días 9 y 11 de octubre en Bruselas. Y esta semana también estamos cumpliendo en el pasado SHIFT, en el 2022, que muchos de ustedes seguro que lo recuerdan. El 15 de octubre del 2022 repatriamos los restos de Blas Cabrera a La Laguna, tras ese injusto exilio, tras la guerra civil que casi borra su memoria. Un 15 de octubre de 2022 fue una gran reparación, porque fue precisamente un 15 de octubre, pero en 1941, cuando Blas Cabrera fue exiliado hacia México. Volvemos a estar en un 15 de octubre 3 años después. Hoy se ha presentado, que tenemos a la directora de Filatelia aquí, Nuria Lera, se ha presentado hoy en la Universidad de La Laguna el sello que homenajea a Blas Cabrera, reproduciendo la curva de las tierras raras, las susceptibilidades magnéticas, el magnetismo que estudió Blas Cabrera. Pues la verdad es que parece como diría, si me permiten la broma, como diría el doctor M. Brown, el Regreso al Futuro, parece un punto de inflexión de todo el espacio-tiempo continuo ese 15 de octubre, ¿verdad? Porque tanta repetición, o podría ser simplemente una coincidencia. Sigamos con las coincidencias. Congreso Solvay de 2025, la semana pasada, su chair, Ben Feringa. Ben Feringa está aquí con nosotros esta noche y nos va a dar la charla sobre, bueno, mejor que se los cuente él, mejor que un premio Nobel. O sea que vamos a dar un fuerte aplauso, give a warm welcome, please, to Ben Feringa. The floor is yours. Thank you.
Thank you, Jorge, for the fantastic words and introduction. It's a great honor and a great pleasure to be here, especially, you know, in this theater. I don't often have to perform in a theater, but I'm a chemist, and I will talk about science and about chemistry. And the joy of discovery is about an adventure in the unknown. This is what we scientists do. This beautiful garden, which is the garden of science, it's like a paradise, full of beautiful flowers where we can discover challenges for our young people, the students, dreams and opportunities for our communities, for our industry, for our society. And of course, questions. That's the most important thing in science. We all know that when you study as a small kid, when you go to high school, to universities, it's about asking questions to Mother Nature, to your teachers. That's the most important. But realize I am a chemist and we build molecules, and I enjoy the beauty of the molecular world. And in the art of building small, we often get lost. This is typically science. You get lost in this beautiful garden, and you come to places where you have never been before. And we hit upon questions that we have never thought about. And these are often the most beautiful and exciting questions because they lead to unexpected discoveries. So this was my horizon when I was a small boy. I grew up on a farm in a village. This was the German border in the northeast of Holland. There was a lot of wildland, and for me, as a young kid, it was an adventure. Growing up on the farm, discoveries, it was possible everywhere. And I always felt like this tiny boy here that was looking at discoveries, because I was reading books as a kid already about adventurers, about Columbus discovering America, Alexander von Humboldt, all these kind of stories, about adventurers. I was fascinated by discoveries. And then, when you think about discovering in high school about elements and about molecules, it is amazing that life came from molecules. You have to realize nature is the greatest chemist on earth. How do we build from molecules? We build the walls of cells, and then ultimately we build the cells of our plants, our animals, and our own body. It's amazing, coming from small atoms all together, and that builds something complex like a human body. And so when you see a cell, nature's greatest chemist, building complex matter, look, a single cell is more complex than the whole city, that we see here around us with everything. Some complexity, and especially also motion, what intrigued me a lot when I started my career. So I often get the question, I build these tiny machines, tiny motors and so, and I will show you one or two examples. And I often get the question, Dr. Feringa, why are you interested? Why do we need these tiny motors and machines? And the same question was asked to the Wright brothers more than 100 years ago. Why do we need a flying machine? If God wanted us to fly, He would have given us wings. You realize nobody would have predicted that 100 years after the Wright brother, we will build a Boeing or an Airbus in Europe that can carry 400 people across the ocean, 1,000 kilometers an hour, 10,000 miles to America or Japan. We admire the flying pigeon, but the Airbus and the Boeing is not flying like a pigeon, It's a marvelous example of modern society where different disciplines come together to engineer something complex like a Boeing or an Airbus. But ladies and gentlemen, we also have to be very modest. 100 years after the Wright brother, we cannot build a pigeon. We cannot build a single cell of the pigeon, not even one of the machineries of the pigeon. This is where we are with science today. So, nature is fantastic. Who has not a smartphone, by the way? Can you raise your hand if you don't have a smartphone? Everybody has a smartphone. Which fundamental scientific questions, new insights and discoveries were needed to build a smartphone? Did you ever think about that? You see, it started 50 years, 70 years ago. We have smartphones only 17 years now. You see, that was in the late 40s, early 50s of the past century that the physics and chemistry built the first transistors and the first liquid crystal materials. Physics, transistors, chemistry, liquid crystal materials, and battery engineers, devices, computer scientists, the programs, and many more. Now we have TikTok, and we have influencers, and we have a lot of work for social sciences these days, thanks to the smartphone. Don't forget, John Goodenow and his colleagues developed the lithium battery in the 80s. Can you imagine? Otherwise, we would not have batteries to power our smartphone. It took 50 years. Only in the 80s. Otherwise, we would not have electric cars today. Yes? This is the way, the joy of discovery, where many disciplines come together and they discover fundamental things and then bring it to an application that we all agree changed our society. When I go to schools, often students say, was there a world without smartphones? They cannot believe that there was a world without smartphones, that we could live as a kid without a smartphone. So, I build molecules and materials in the laboratory. We have a universal language, the language of atoms and molecules, and we have a passion for discovery. When I go to China, I don't speak Chinese, but when I go to a school and they know something about molecules, they know this is sugar. This is our language of chemistry. And we have, of course, the periodic table of the elements. So this is, did you ever think about it? The molecular formula of your own body. You see, hydrogen 375 million, oxygen 132 million, carbon, and one lonely cobalt. Professor Martin, can you stand up for a second? Can you look? Look, this fellow, you see, this is what hydrogen and oxygen. You know why? 60% water, plus a few other molecules. This man looks really handsome, no? Very good shape. 60% water. Thank you so much. Now the question, as you all have a smartphone, ladies and gentlemen, you know now what the elements in your body are. Now the question, are there more or less distinct elements in your smartphone than in your body? More or less? Okay, I'll give you the answer. A smartphone, chemistry-wise, is more complex than your own body. There are more distinct elements in a smartphone than in your body. Did you ever think about that? I would argue that your body, a living human being, is the most complex thing on earth. But a smartphone is pretty complex from a chemical perspective. Okay, this is how we do chemical synthesis. It's like Lego, yeah? We play in the lab, building molecules. This is Taxol. Don't look too much at the structure, but we build it step by step. A plus B goes to C, goes to D, E, etc., etc. This needs a lot of chemical steps to build it. And this is a life-saving drug for many women because this is Taxol, and it's, when you have breast cancer, yeah, you get Taxol. It's very effective for treating breast cancer. But it's extremely complex to make. So this is what we do. We build drugs, dyes, cables, cars, the components of your clothes and smartphone. This is typically what chemists do. Not in isolation, but of course together with our colleagues from physics, from biology, medicine, yeah, engineers, people in industry. But this builds modern society, ladies and gentlemen. So to all chemists in the audience, be proud to be a chemist, because that builds modern society. But we cannot make anything that moves. You know, I move, I can wave my hands, I can see, I can talk. And so this is a motor in your body. This is the ATPase rotary motor. It is a few nanometers in size. I'll come to that in a second. And I showed this earlier this week, yeah, but it's so beautiful. There are billions and billions of these motors in your body that make the fuel in your body, the ATP, the fuel. I asked this question earlier, and so those people who know the answer, don't give the answer. How much fuel do these tiny nanomotors produce every day? Every 24 hours, half your body weight. Can you imagine? Half your body weight? I like Spanish food, but I don't eat half my body weight every day. So this is all recycled. And what is one of the most important problems we see almost every day? Recycling our materials, recycling plastics, recycling our materials. Come on, guys, we are not smart enough yet. Your body recycles half your body weight every day with these tiny nanomachines. So there's a lot to be discovered, and that's what we do. Oh yeah, we just heard rock music, and my students found this on the web, Twitter, March 22. This was me, apparently, when I started my career as a junior professor at the university. And he said, Twitter said, we chemists are lucky he chose academia instead of becoming a rock star. You know, I cannot make music, don't ask me. But look, this is what I said when I started many years ago. The beauty of chemistry is that I can create my own world. We design molecules and materials, as I showed you before. This is what we do. So I became, a scientist, and I enjoy music, of course, don't worry, but I cannot make music. But I enjoy discovering molecules. And so we built molecules in the laboratory, as I mentioned. And first about this nanotechnology, you see here one hair? Can you see it? One hair? Yeah? No? It's small, eh? One hair. One hair, the cross-section of a human hair, is 80,000 nanometer. 80,000 times bigger than the size of our tiny machines. Just to give you an idea. 1 nanometer is 1 billion of a meter. Does size matter? Yes, it matters. When you go to the beach, and you go to a pebble beach, or you go to a nice sandy beach, you drop down, you know how it feels, eh? It makes a big difference. So this is, of course, nanotechnology. We heard this also this week at the conference. Beautiful examples how size can affect all kinds of properties, eh? And we know hard, soft. I will talk about soft things, yes? And this is what we made. A molecular motor, the tiniest motor in the world, powered by light, energy from the light. It rotates, as you can see, and it's 1 billion of a meter in size, 80,000 times smaller than the cross-section of a human hair. And you see it rotates in one direction. The tiniest motor in the world, completely synthetic. We can make it rotating in this direction, we can make it rotating in the opposite direction. Now, I'm here in Spain, and you know in Holland, we built these old windmills. When we still belonged to Spain, in those days, 16th, 17th century, we built these windmills, you see, the tulip fields. Now we have modern windmills. But I know also in Spain you like windmills a lot, eh? So I was asked, challenged, can you build a nano windmill? And this is what we did. You see, this is what our ancestors did 500 years ago. They are 20 meters in size, and we built a tiny windmill with 2 legs. You see, it stands on the surface, and they are 2 nanometer, 1 billion times smaller. So we have a surface, yes, covered with these tiny windmills. And then you will ask me, these students at the university with you, what are they doing? Playing Lego? Building nano windmills? Why do we should give money to the universities to do this kind of research? That's a good question. But look, what we built windows with a cover that clean themselves when the sun shines. You don't have to clean your windows in the future anymore. Or solar panels. It's not a problem in Holland because it rains a lot. But when you are here in the south of Spain, for instance, or whatever, and you have a lot of dust on your panels, the efficiency goes down, and we know that. We heard about it this week, about efficiency of solar converters. The cars. In the future, you will have a coating, and due to the sun, the surface moves, it will clean itself. I've seen the first examples now of self-cleaning surfaces. But even more important, when you have a scratch in your car, or a scratch here, it does not repair itself. When you have a scratch in your car, you might be not so happy because you have to go to the garage. But in the future, I had a cut in my finger. When you keep it clean, it repairs itself, and you don't have to do anything. This is Mother Nature, lifelike properties. In the future, when you have a scratch in your car, maybe in 30 years from now, It will repair itself with the light and the energy from the sun. This is what will happen. Self-cleaning, self-repair, all these type of materials. So we built also a nano car. You see, this is a solar-powered car with the solar panels, 2 meters in size. We built one that is 2 nanometers. This is 4-wheel drive. You see, 4 of these motors, they rotate, yeah, and it's powered by solar energy. Does it move? Yes, ladies and gentlemen. It moves over a surface. It took us 8 years to build it, with five scientists working on it continuously. But we finally could make it, and it moves over a surface once you illuminate. And so, here you see it moving. Here you see a picture of 1 nano car, 2 nanometers in size. Thanks to these new techniques and so in the laboratories, we can measure, we can see it. You see it moving here. But realize the nano world is a bit different than the macro world. Can we shake hands once again? You see, when we shake hands, you feel your muscles, And there are all these tiny motors, millions of motors. Yeah, he is way stronger than I am. Many more motors. But you have these motors and make it possible that you can move your arm. And this is how it works in your body, and this is how my car moves. Look. It walks on the nano scale. Welcome in the nano world. And if you don't believe me, this is how it really walks, over the surface. And now I show you how it goes in your body. Look. This is now happening in your body, in your cells. You see, the highways, the motorways are built when something has to be transported. And when the car is passed by, they detach. And when a new car comes, they build a new highway. And look, this is now happening in all your cells. Nanotechnology, nano movement, nano transport. Look, can you imagine you are alive when you see this? This happens in your cells now at the nano scale. So there was also a Formula 1 race for nano cars. You see here a nano car race, 36-hour live race, Formula 1 for nano cars. It was in Toulouse in 2017. That's where we are. So, let me conclude. Will we have nano robots? You remember, certainly the senior people in the audience, the Fantastic Voyage from Asimov, this beautiful, that a robot, went through your body to the defect in the brain to repair. Will we have nano robots? Is it science or science fiction? At the moment, it's maybe science fiction, but in the future, it will be a reality. I'm not good at predicting the future. I'm a scientist. So the best way to predict the future is to invent it. And this is what we do as scientists at our universities, at our research institutes. But I predict that in 50 years from now, the surgeon will inject a nanorobot in your body to do a repair, or deliver a drug precisely where it's needed. So you know this guy, You remember? This Dutchman, this was his playing ground. Sorry, it's the Barcelona playing field. But what is our playing field? Because you might imagine, so many discoveries have been made. Is there still space to discover? This is my playing field. To create molecules, materials for the future. And our playing field, if we calculate a simple molecule like Taxol, this anti-tumor compound, this is our playing field. These are the number of molecules that you can make, This is more than all stars, all material in the universe. So we have scratched only the surface. We have discovered only a tiny, tiny bit. It's unlimited. And then, because we started with music, let me start with finish with some Dutch music. Because we were challenged, my students, to dance their PhD research. That was a science contest. Actually, we got an award from science because my students danced, yeah, their PhD. They had to express, yeah, by a dance, how the motor functions. Sorry, it's not rock music, eh? That's the life, Professor. So let me finish. Discover your future. With Albert Einstein, knowledge and creativity and imagination is really sustainable in this world. As Albert Einstein said, imagination is more important than knowledge. Imagination and creativity encircles the world. Thank you very much.
Thank you very much. Thank you very much.